Michelangelo once said, "If people knew how hard I had to work to gain my mastery, it would not seem so wonderful at all." Talent is built upon the idea of innate ability rather than practice, which determines whether we have it within us to achieve excellence. This idea seems demoralising of one's ability who sees success as improving ability rather than those who have the right genes. So what is talent? Michaels et al. In 2001 posited that talent is a fundamental belief which is needed to achieve a field of excellence. However, Howie et al. In 1998 argues that it is clear that certain pitfalls have to be avoided in settling on a definition of talent. For instance, in our own observations, the nature of having a restricted viewpoint could make it impossible to have a general characterization of talent. But then, some definitions of talent are so vague, we are pointed to ask what is the point of using the term at all. In 1991, Anders Ericsson investigated performers and was looking for talent, but he couldn't find any. The biographic history of his subjects was so similar that they showed no systematic differences. The only obvious difference was the amount of hours dedicated to practice. The top performers' subjects dedicated over 10,000 hours, 65% more than the bottom performers. The only factor which distinguished the differences was purposeful practice, which disagrees with Malcolm Gladwell's 10,000 hours theory, as it did not unlock success on a global scale. However, no person who played chess did not achieve a level of grand mastery without a decade of practice, and so it can be said that no conclusive findings of what is the correct amount of practice can come from Gladwell's study. Not all practice is equal. When people practice, they practice what they can do effortlessly, according to Fielding et al. In 2005. Throughout regular findings of research, it is stated that it is not only by working at what you can't do, which turns you into the master you want to be, which is called deliberate practice. Pantelopoulos in 2012 describes that excellence is built upon the foundations of failure. Baker, Cote and Deakin in 2005 argued that deliberate practice is predicted upon the concept that it is not only simply training of any type, but the engagement in specific forms of practice that is necessary for the attainment of expertise. The types of training activities that fall within the definition of deliberate practice include activities undertaken to develop required capacities which are not yet enjoyable to perform, require effort and concentration, and do not lead to social or financial rewards. Gold and Diffenbach in 2002 point out that participation in deliberate practice is physically and mentally demanding. Therefore, adequate periods of recovery are required to prevent physical exhaustion as well as mental staleness, burnout or motivational problems. Ericsson and Moxley in 2012 reiterated this claim, stating that the concept of deliberate practice can account for the large individual differences between experts and novices. The results of a moderator analysis of 88 eligible studies is revealed in biological perspectives. The results do not support the claims Ericsson made. Regardless of a domain, a large amount of variance in performance is not explained by deliberate practice and potentially explainable by other factors. In a move away from traditional approaches to acquiring talent, a potentially valuable conceptual framework for modelling the acquisition of expertise exists in understanding performance as complex dynamical systems. Complexity sciences have been used to study and explain the patterns formed in complex sciences, such as animal collectives, weather systems, the human brain, and movements in team sports, where patterns emerge from seemingly random component trajectories, according to Phillips, Davids, Renshaw, and Portis in 2010. The new perspective sees the adaptations in performance occur as a result of system trade-offs between specificity and diversity of behaviours. Dynamical systems theory emphasises the influence of interacting constraints on performance and how expertise can be achieved in diverse ways as athletes attempt to satisfy the unique constraints placed upon them. For example, Simerton proposed that talent emerges from multidisciplinary, multiplicative and dynamical processes and is likely to operate as an interdictive system beyond the scope of nature versus nurture debates. He pioneered mathematical equations to operationalise the potential components that contribute to talent development. The components were weighted by relevance and included reference to genetic dispositions, environmental and developmental constraints. It was seen as an epigenetic and epigenetic comprising components that interact and change with time. The capturing of epigenetics within the model was seen as diverse components that make up talent, which gradually appear and differentiate over time in an individual and depend on underlying neurological, muscular, cultural, skeletal, social, psychological and psychosocial and environmental variables. We are not born with the genes that makes us talented. We become better with practice. Much to Darwin's theory of natural selection, animals adjust to characteristics in order to survive. Us as humans do that with skill practice. There are no world-class performers who become what they are without hours dedicated to learning and improving. And this is what we call the iceberg effect. We only see the success and not the hours of dedication, injuries and sacrifices along the way. In some ways, we become successful by just believing in the abilities which we already have.